The science behind vaccines. Every time you get a vaccine, whether it's for the flu, COVID-19, or childhood diseases like measles or polio, you're witnessing one of humanity's greatest scientific achievements. Vaccines have saved more lives than any other medical intervention in history. But have you ever wondered, how do they really work? How does a small shot in your arm train your body to defeat deadly diseases? Today, we'll uncover the fascinating science behind vaccines, from their discovery to how they prepare your immune system like a high-tech army, ready to defend your life. Part 1. The origin of vaccines. The story begins centuries ago. In the late 1700s, smallpox was one of the most feared diseases on Earth, killing millions every year. Then came Edward Jenner, an English physician who noticed something strange. Milkmaids who caught cowpox, a mild disease, didn't get smallpox. In 1796, he tested his theory by taking fluid from a cowpox blister and introducing it into a young boy named James Phipps. Weeks later, when Jenner exposed the boy to smallpox, he didn't fall ill. The idea worked. It was the birth of the first vaccine, the term coming from vacca, the Latin word for cow. That single experiment started a revolution, one that would eventually lead to the eradication of smallpox by 1980, saving hundreds of millions of lives. Part 2. How vaccines actually work. To understand vaccines, we must first understand your body's defense system, the immune system. Think of it as a highly trained army with two main divisions. The innate immune system, your first responders, acting fast but non-specifically. The adaptive immune system, a specialized force that learns and remembers enemies. When a virus or bacteria invades, your body identifies it as foreign, using molecular flags called antigens. These antigens trigger immune cells to produce antibodies, Y-shaped proteins that attach to the invaders and neutralize them. But here's the catch. It takes time for your immune system to recognize a new pathogen. Sometimes, by the time it's ready to fight, the infection has already caused severe damage. That's where vaccines come in. Vaccines give your body a safe preview of a pathogen without causing the full-blown disease. This could be done using killed or weakened forms of the virus, like in polio or measles vaccines. Only a piece of the pathogen, like a protein or sugar, like in hepatitis B. Or even a snippet of genetic code that makes your cells produce the viral protein, like in mRNA COVID-19 vaccines. Once your immune system sees these harmless versions, it creates memory cells. So when the real virus appears later, your body instantly recognizes it and attacks before you even feel sick. Part 3. The types of vaccines. Over 2 centuries of innovation have led to different types of vaccines. Live attenuated vaccines. These use a weakened version of the pathogen. Examples: MMR, measles, mumps, rubella, chickenpox. They give strong, long-lasting immunity. Inactivated vaccines. These use killed pathogens like the inactivated polio vaccine or flu shots. They're safer, but may need boosters. Subunit or recombinant vaccines. Instead of using the whole germ, they use specific pieces like proteins. Hepatitis B and HPV vaccines are great examples. Toxoid vaccines. Some bacteria cause illness not by themselves, but through toxins. These vaccines train the body to fight the toxins. Examples: tetanus and diphtheria. mRNA vaccines, the newest type. Instead of the virus, they deliver a piece of genetic code that teaches your cells to make a harmless version of the viral protein, training your immune system without the virus itself. Each type has its pros and cons, but all work toward one purpose: training your immune memory. Part 4. The science of immune memory. When you get a vaccine, your immune cells, specifically B cells and T cells, become educated. B cells create antibodies that neutralize pathogens. T cells destroy infected cells and support the immune response. After the initial exposure, most of these cells die off, but a few remain as memory cells, like veteran soldiers who remember every detail of the battle. Years, even decades later, when the same germ tries to attack, these cells recognize it instantly. releasing antibodies within hours. That's why even one childhood shot can protect you for life. Part 5. The impact of vaccines. Vaccines have changed the course of human history. Before vaccines, diseases like smallpox, polio, and measles killed or disabled millions every year. Today, thanks to global vaccination campaigns, smallpox is eradicated. Polio is nearly gone. Measles deaths dropped by over 90%, and diseases like tetanus, rubella, and diphtheria are rare in many countries. According to the World Health Organization, vaccines prevent more than 4 million deaths every year. They are second only to clean water in improving human life expectancy. Part 6. The mRNA revolution. The COVID-19 pandemic introduced the world to mRNA vaccines, a technology decades in the making. Unlike traditional vaccines, mRNA vaccines don't use the virus itself. Instead, they send instructions, mRNA, to your body's cells, telling them to produce a piece of the virus, such as the spike protein. Your immune system sees this protein, identifies it as foreign, and builds protection against it. This approach is faster to produce, easier to modify, and may lead to future vaccines for cancer, malaria, and even HIV. It's not science fiction. Clinical trials are already underway. Part 7. Myths versus facts. Despite their success, vaccines are surrounded by myths. Some people fear that vaccines cause diseases or alter DNA. The truth? Vaccines do not change your genetic code. They cannot cause the disease they prevent. And side effects, like mild fever or fatigue, are signs your immune system is working. Every vaccine undergoes years of clinical trials before approval. Even after release, they're monitored for safety worldwide by organizations like the WHO, CDC, and EMA. Part 8. The future of vaccination. The future of vaccines is astonishing. Scientists are working on universal flu vaccines that work against all flu strains, needle-free patches that dissolve on your skin, personalized cancer vaccines that train your immune system to recognize tumor cells, and even AI-designed vaccines created in days instead of years. Vaccines are no longer just for preventing infection. They could soon treat diseases like Alzheimer's or drug addiction. Conclusion. From a cowpox blister in the 18th century to mRNA microlabs in the 21st, vaccines represent humanity's power to learn, adapt, and protect itself. They are a triumph of science and compassion, proof that knowledge can defeat fear. So the next time you roll up your sleeve for a shot, remember, it's not just a needle. It's the result of centuries of discovery, collaboration, and courage. Vaccines don't just save lives, they define what it means to be human. Hey Tech Explorers, you've just watched Honest Facts, where curiosity meets innovation. If you love this video, subscribe now and tap the bell icon for your weekly dose of smart facts.